Okay, on the third and final statistics video, we're going to talk about regression. Regression is a method used it's a method used for prediction. All right, so if you have some data, you can use regression to model that data with a specific formula. For example, let's say I had, midterm scores and final exam scores. You guys remember that midterm, right? Yeah, that was fun. So let's say I had, here 65 and a 67. Landon, that's definitely you. And here 90, 85. Tom's 50. Tom, you did even worse. You got a 40 on that one. Now, these aren't students from my class. They just happen to say Landon and Tom. So, just kidding. 80, 85, 92, 96. So let's say I had these scores. All right, here's the midterm. Here's the final. Well, if I were to plot these, what I would do is I would go to Stat, Edit, go up to the top, clear it down, down, clear, hit the down arrow. Let's put these in: 65, 90, 50, 80, 92, 67, 85. Darn it. Darn it, darn it. Good. Nope. What happened here? 65. Let me do this over. 90, 50, 80, 80, 92. All right, finally, we got the data in here. If you go second stat plot, hit enter, want to make sure the plot is turned on, go right here. That's a scatter plot. L1, L2, then I hit zoom 9, zoom statistics. It gives me a nice quadrant 1 statistical window. So this function looks like a straight line would model it, perhaps. So this looks pretty linear, right? If the dots were going like this, that's exponential. So what you can do here, part A, find the best fit line for the data. So I'm going to hit Stat, Calc, Linear Regression, L1, L2. No, there's no frequency. L1, L2, blank, blank, hit Calculate. So Y, sometimes I say Y hat, is A X plus B. AX plus B, that's the best fit line. So it has a slope of 1.2, a y-intercept of -15. Now, if you don't have the R squared and the R, you would have to hit second 0, second catalog, and you could hit D, and then you'd have to find diagnostics and turn them on. Let me just get out of there. R is your correlation coefficient. R squared is your coefficient of determination. Now, this isn't in this course, but you want a high R squared. You want a really high R squared. That means your model is a pretty good fit for the data. So if I wanted to predict a final exam score for Fiona, and her midterm score was, Fiona, you remember what you got? Fiona? All right, she's not responding. A midterm score was, let's say Fiona got a, 94. So what I do, see, I don't have her score on here, but let's say that she did. I would plug that in to the best fit line to predict what she probably would get. So 1.2 times 94 minus 15.7. And my line is telling me 97.1. That's the prediction. All right. See, watch what happens if I said, see, find the best fit exponential model. So what I would do is I would hit Stat, Calc, scroll down to exponential regression, L1, L2, blank, blank. If you have the old operating system, it would say this, and then you'd have to hit second 1, comma, right by the 7, second L2, wherever your data was, and then hit enter. So this says y equals a times b to the x. A is 17.4 times 1.02 to the x. Maybe this model predicts it better than the linear model. My r squared is higher. No, my r squared is lower. It's still pretty good though, but my r squared is lower. So because my r squared is lower, I'm thinking that this model would be better, but that's okay. They will tell you in the regions which one they want you to do. So 17.4, let's say I wanted to use this equation to figure out what Fiona would get. 1.02 to the 94. Wow, Fiona, look at that. You got 111.9 in that final exam. Okay, you're in great shape. See, this model is not good because you can't get over 100, and, well, this is a disaster. All right, so, yeah, no. Exponential models would be more for bacteria, double time, half-life, some sort of growth that's not linear, something like a geometric series. So let me see if I can find an example. Well, I thought I printed one of them out. Oh, okay. 401. The price of a postage stamp in the years since the end of World War I. So that's 20 years after the end of World War I. When did World War I end? I don't know, 1942, or is that when it started? I'm not sure. We're going to need Mr. Scott on that one. So, yeah, here's the price of stamps. Definitely not keeping up with inflation. So the equation that best models the price is, well, see, this is linear. That's like y equals mx plus b. That is not a line, so that's not going to work. It's not sine. Sine looks like this. That's a sinusoidal regression. That's not true. These are both exponential. Well, which one is it? So what I would do is I would plug in that value and see if it kind of gives me this. So plug in 60 for x, 1.04, 1.43 to the 60th, 1.43, 1.04 to the 60th. See, I can't put the data in the calculator, so here, 1.43 times 1.04 to the 60th. That's about 15.04. That's probably it, but let's try the other one. 1.04 times 1.43 to the 60th. Whoa, It's certainly not it. So it's this one. All right. Next type of question, 402. The relationship between weight and time is, okay, well, these are all exponential. An exponential has the x in the exponent. So we got to see which one it is. All right, so you'd have to just kind of plug in values. So 1, 2, 3, 5. All right, so if we plug in 3, we should get around there. So 4 to the 3 plus 5, that's 64 plus 5, that's 69. Nope. 1.4 to the third power plus 2, that's about 4.74. 2.1 to the third power times 5, that's about 46. 0.75 to the third power times 8, that's about 3.375. All right, so maybe it's these two. Let's plug in another value and let's see which one's closer. So let's say we plug in 4, 5, 6, 7, 8, 9. Let's plug in 9. 1.4 to the 9th power plus 2. That's about 22. 8 times 0.75 to the 9th power. It's 0.6. Well, yeah, 22 makes sense, so it's this one. It's choice 2. 403, write an exponential regression equation. So, stat, edit, plug in the values. Hudson is not a happy camper upstairs. And he wasn't a camper to begin with. All right, so we hit stat. There's all sorts of different regressions you can pick. But exponential. Here it is. Y equals 4.17 times 3.98 to the x. All right. And then this question says here, I can't exceed 100. So it says use this to determine the maximum amount of time it would take to get to 100. So one way you could do is go to y equals, and you could put this equation in there. And then put 100 in for y2. Okay. Zoom. Go to zoom 6. That gives you a 10 by 10 window. So there's the equation. There's the exponential equation. All right, now it's got to go to 100. So here, let's change the window. Let's do the y, the maximum y's. Let's go to 200. Oh, I got to get rid of those points. Or maybe not. So I got to find out where that intersection is. So hit second, trace, intersect. So scroll to it, hit enter, hit enter, hit enter. So when x is about 2.3, so anything above 2.3 hours that meat is left out, you're going to have bacteria spores over 100, which makes sense because at 3 hours you're at 260, at 2 hours you're at 60, so it's got to be somewhere between there. All right, hope you guys have had fun. Listen, I pumped out a lot of these videos fast because I don't know if I'm going to get sick. I don't know if my wife's going to get sick. And if that happens, I'm not going to be able to do these. So I wanted to spending hours getting everything out so that you guys at least have these. I don't know if we're coming back to school or not. So at least we have them all set. So we are done with this entire course. It is now up to you to maybe go on that website, practice some questions, or download some old Regents exams, practice questions. I'm going to send you some links of other resources of, I think there's other like YouTube videos that teachers have made that they go through old exams, which can be kind of good. Are we still going to have a Regents exam? Who knows? I hope we don't. They pass everybody, give everybody a 90. Wouldn't that be nice? Or above a 90. I think that would be pretty good. Let's not worry about that yet. Let's just worry about learning what we have to learn. And then we're going to wait till 420 to see if we're going back to school or not. So enjoy. And like I said, reach out to me if you have any questions or need help with something. Adios.